Hey guys, how's it going? So in this tutorial, I'm going to show you guys how to run Quantum Espresso on a Windows PC, and that too in parallel. So basically all the cores on your machine, that is your processor, will be utilized. So if you have a multi-core processor such as a dual core, quad core, hexa-core, or even higher, then you would be able to take advantage of those extra cores to run Quantum Espresso in parallel. So the first step to do is to head on to the homepage for Quantum Espresso, that is quantum-espresso.org, and head over to the download section. So once you're at the download section, there's a bunch of information about how to cite Quantum Espresso, then how to download. So what you have to note here is that these two links basically will provide you a source code or source package of Quantum Espresso, not a binary. So the difference between a source package and a binary is that a source package needs to be compiled to be able to run it. However, binary is basically just a .exe or .x file that can be just double clicked and run straight away. So if you are going to compile it by your own, which this tutorial isn't about, then you will usually head over to this section. However, for Windows users, what you can do is to download the Windows binaries. You can go to this link, that is Advanced Software Corporation. So what these guys have basically done is they have been nice enough to have compiled a very recent version of Quantum Espresso, that is 6.2.1, and provided the binary files for Windows as well as Linux. Now the important thing to note here is, basically, as I already told you, that you have to take the source code and compile it on your own to be able to run on your PC. So the major factor about why people want to provide this freedom about compiling the software on your own is so that you can use your preferred libraries. So what they have provided here is their binaries are basically compiled with Ming W64G, Fortran, Intel MKL, and Microsoft MPI. So what this does is basically, it doesn't guarantee that this binary will be able to run on your PC or not, depending if you have these required libraries or not. So luckily, in my experience on Intel processors running Windows 10, I found no problem in running these binaries. So basically you can ignore this section about binary files of QE for Linux and then head over to binary files of QE for Windows and then download this QE.zip. So, and another disadvantage of downloading this binary is that it is a pretty old version, not a very old version, but yeah, current version of Quantum Espresso is 6.4.1 and it's only 2.1. So I won't go ahead and save it again. It's around 352 MBs, but since I have already downloaded it, so I won't be saving it again. However, I should also note here that if you download the binary files of Linux, so in my experience, I wasn't able to run these right out of the box, so I had to compile them on my own. But the problem is, I know how to compile the binary files for Linux. However, I don't know how to do the same for Windows. So anywho, let's coming back to the theme of the tutorial, that is how to run Quantum Espresso on Windows in parallel. So once you download it, you will have a QE.win file. However, you can also download an mpi.zip file. However, I'm not really sure how this would be coming into play. However, I've downloaded them both and then extracted them both right here, and also if you have more knowledge than me about how to compile it for Windows and all that stuff, then I'll be happy if you would be willing to leave a comment down in the comment section down below. So help other users out if you can. Anywho, so just extract this QE.win, this QE.zip file over here, and you will get a folder called QE, and this would have all the binaries needed for Quantum Espresso. So if you are previously familiar with Quantum Espresso, then you would be expecting a p.w.exe, a bands.exe, a mat.dyn, I saw that here, right here, and then bands.exe, and a lot of the usual exes. So now let's do a sample run and see if this works or not. So here I have a test run QE folder which has an scf.input file for an SCF calculation using Quantum Espresso. So let me just go ahead and show you guys a little bit of what this file has in it. So basically it would be an SCF calculation for our test run, then the standard input like max seconds. And one very important thing to note here is that whenever you are providing the address or the directory for the sudo directory or the temporary directory that is out dir argument, then what you have to keep in mind is you have to use forward slashes here instead of the backslash. So usually on Windows, basically if you see right here, then you can see that Windows usually uses backslash. However, for some reason on my PC I couldn't get it to work with backslashes, so I had to use forward slash, which is similar to what you will do on a Linux PC. So anywho, so then we have the sudo directory providing the sudo potential, then the the argument to calculate stress as well as forces. Then basically it is an iron BCC structure, so we have an iron atom at the origin and another one at the center of the lattice or the cube, and then the standard stuff, k point 6 by 6 by 6, some information regarding these parameters and all the standard stuff. And you can also see we'll be doing a spin polarized calculation. So as you can see, there is nothing fancy about this input file. Basically, I mean, it is basically identical to any input file that you will create for Linux. So there is nothing new that you will have to take care of here. So in order to run this calculation, what you will do next is you will head over to command prompt. So just go ahead and run that. So here I am. So let me just come to this directory real quick. So I'll just head over to my desktop, and then it was let me see, test run. Yeah, test run. Okay, so here I am, and so the command to run this input file is pretty easy. So I'll need to go to the folder where I have downloaded QE and extracted it. So I had QE downloaded here, and then I extracted the zip file to get this. So then what I'm going to do is I'm going to find pw.exe, which is this file right here, open my command prompt, and then just drag this pw.exe here so that I'll get the address, and make sure that you have double quotes around the address. And then the procedure is pretty simple. So you're already in the directory that contains the input file, that is scf.in. So let me just take care of a few stuff. Okay, so you're in the directory containing the input file, then you have provided the address for the quantum espresso pw.exe executable, and then just hit a space, triangular left arrow, and the name of the input file, that is scf.in, triangular right arrow, and the name of the output file. So let's just call it scf.out, and then hit enter. So what you'll notice here is, okay, so it is asking you to provide some access, and just go ahead and click on allow access. I think it asks for those permission because it's meant to run on a multi-node environment as well. So if you have a multi-node PC, maybe it needs to access some networks. Again, I'm not an expert over here. So what you can notice here is that the calculation has already completed. So just go ahead and click on scf.out and open it in your favorite editor. And by the way, I always use Notepad++, so shout out to Notepad++ team. So what you can notice here is in the starting is that it is Quantum Espresso version 6.2, and then you can also notice that it is a parallel version running on 4 processor cores. So basically a single MPI process, because it is basically a single node, and then threads basically 4 because I'm using a dual core i7 on my laptop, and it has 2 threads per core, so I guess 4 threads from that. And the MPI processors are distributed on a single node, and then basically standard stuff. And in a few moments you will see that the calculation has completed successfully, so the job done. And you can also see the total energy, the absolute magnetization, total magnetization, and all that stuff, forces, stress. So the calculation was successful. So I guess that's it. That's how you run Quantum Espresso in parallel on a Windows PC. So just follow the similar procedure for this. If you have even any other calculation, like if you are going to use bands.exe, then just replace pw by bands. However, I should also take a moment to discuss one really annoying problem with running Quantum Espresso on Windows is that when I'm running bands.exe or a similar file which has an ampersand plot name list, so basically a plot name list, whenever I have a plot name list, then this doesn't work for some reason. So maybe I am doing something wrong. I'll be happy if you could share your experience in the comment section down below. However, that's it for this tutorial. That's how you run Quantum Espresso in parallel on a Windows PC. I hope you guys enjoyed it. If you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. I have a bunch of tutorials on Quantum Espresso and similar software. And that's it. Thanks for watching and have a great day.